Hello, everyone, and welcome to today's SANS webcast, ICS Proactive Defense, Leveraging Operational Threat Hunting for Resilience, Part 1. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Dean Parsons, SANS Certified Instructor. If during the webcast you have any questions for Dean, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dean.
All right, thanks so much, Carol. Appreciate that. Welcome, everybody. Want to talk about a really exciting topic that hopefully we can all take part in over this series of 3 webcasts, maybe more, on threat intelligence and using threat intelligence for ICS hunting. So we're going to dive right into the content because we have a lot of it even in this first part. Just a quick introduction, a little bit of information about myself. Dean Parsons, certified instructor for ICS 515, but also I teach the new ICS 418 class as well that I co-authored with my cohort and partner, Jason Christopher, as well. I have around 20 years experience in IT and converged IT, OT, ICS environments, building teams, doing packet analysis, but also preparing policies for the board and a whole range in between. Focus mostly on telecommunications the first 10 years, but the last 10 years been focusing on ICS specifically in power generation, transmission, distribution, also recently in oil and gas refineries, marine terminals, storage facilities, and so on and so forth, and assessments related to industrial control systems and critical infrastructure today. So anything between cookie factories and critical infrastructure, let's dive right into this content, which is applicable in those areas. So this is the first of this web series on threat hunting in industrial control environments. So today we're going to talk about the what hunting benefits you can get, and also when to start. When's the best time to start, and when you're going to get the most value. And the other 2 parts, data sources, will become really apparent after this one, which will build, of course, and then get us to number 3 in a little bit of time after these couple. So, and that'll be talking about using walkthroughs on screen of actual threat hunts and so on and so forth. So part 1 is really going to talk about the benefits and when to start. So we'll talk about the definition of threat hunting because there are several definitions out there. We'll apply that though to the industrial control or OT sector first and talk about how you can get there. And if you're already there, awesome. And you'll also see the benefits from what you're doing today for threat hunting. We'll also kind of finish out this deck today with no-cost threat intelligence sources you can use at any point, and perhaps you're using some of those today. But if not, there's 12 or 13 of them that we're going to provide in this webcast. We'll finish out with a top 5 or 6 items to take away from this particular part, and then it'll drive us to the next one after that. So let's get into the definition very quickly, and then we'll jump into more of the when and how and benefits. So threat hunting, what is it? Very, very basic definition, so bear with me. A threat is a person or thing, which can be cyber, right, to cause damage or can have some kind of danger or impact in the environment. That's what a threat can do. A hunt is really specifically looking for or searching for those things, that's someone or something. Of course, we're going to adapt this hunting to our cyber environment, specifically in the industrial case for us. So bear with me. I know this is a lot of text on this slide, but I emphasize key words to really draw out what threat hunting is and how we're going to apply it specifically to an ICS hunting environment or a specific OT security program. So bear with me as we jump in. Threat hunting is a proactive process performed at a regular cadence. We'll get into timing later. Performed by human defenders, leveraging threat intelligence sources. Some of those are coming later. Leveraging the threat intelligence sources to create threat-driven attack hypotheses. We'll also then talk about sifting through the data of security event-specific data in the ICS. And of course, all of this is to stop an attack in progress, or if there is no attack, at the same time, you're strengthening your security program before there is an actual incident. So a lot of words there. Proactive, human defenders, threat-driven hypothesis, right, with a purpose, strengthening your program, even if you don't find adversaries. So all of this will become evident as we kind of pivot through. So threat hunting is not new, and it's not new in IT or ICS. In fact, IT has been doing threat hunting for decades, and it's just been called something different, but it's really proactive cyber defense. So what we're going to do is we're going to leverage what IT has done for a long time, and there is differences to how to adapt and use and do threat hunting in the ICS. So again, IT has been using it for a long time and doing these processes for a very long time. Nothing new, but there are some things that are different between IT and ICS. Generally, the concepts of hunting, finding those adversaries in the environment or traces of them before an event happens or actual impact happens remains the same. Concepts are the same. The technical approaches are mostly the same between IT and ICS as well. The concepts are there, and the technical approach will be to getting data, pivoting through the data and understand if the adversary is there, find the vector, find what you can do to reduce the habitable nature of your environment from the adversary's perspective, and so on. Now, the differences here I want to really touch on for a couple minutes is the approach for ICS specifically. Now, threats in the business network look very different than threats in the industrial control system environment. So it just goes to show that we have to take a different approach when we're hunting for adversaries that have to use different techniques for their attacks. So specifically the safety aspect in the environment in ICS. So we know that there's safety systems in there as an example, but we have to treat our environments as safe as possible as well, even when we're performing the actual hunting. Now, the assets is another big difference in IT and ICS. There are more different kinds of assets in OT, which means we have things like engineering devices, for example, embedded operating systems. Of course, in ICS as well, we have some legacy gear that will probably still kick around for a bit. And that means we might have legacy data and logging capabilities, or at least lack thereof capabilities for logging. And this might impact your environment with how effective your search can be. Rest assured, we can tell you about some of those things you can enable to get the best logging for the ICS. Beyond that, of course, when you're hunting on the network, specifically in ICS, the network protocols are very different than a business network. So you will see industrial protocols on the environment. So that approach is going to be different with how to sift through that data. And the technical tools you and your team will use need to be ICS aware, if you will. Now, beyond that, of course, the attacks we kind of talked a little bit about. I'm going to give you an example later. The attack structure and methodology, the techniques, the tactics used in ICS to have access, execution of an attack, or the manipulation of control to have an impact in the ICS is also different. So looking for different things in the ICS is going to be really kind of tied to how the adversary has been operating in the ICS. Now, when we take a look specifically at industrial control environments and what we are going to assume about traditional ICS security, we're going to walk through these steps. And at the back of our minds, we're going to consider that what you see on the screen is just a normal controller for the industrial environment, but this is not a typical Windows box by any stretch. So it kind of points out the differences. So in this case here, we know in general with threat hunting, we will assume that traditional defenses will fail. Same goes for IT and ICS in this case. And we have to hunt. Hunting allows us to be proactive in the environment. So those of you who do a really good work at scoping and using indicators of compromise, awesome. We're hopefully going to try to position another opportunity that not only does scoping, but also proactively changes the environment before you have an incident. So it reduces the need for actually finding incidents in your environment using only indicators of compromise. So this is really the proactive approach for industrial control system incident response, threat hunting, but also in IT as well. Now, specific to the industrial control systems environment, when you are threat hunting, it's I would say there's different data you're looking for, but it can be a little easier because network security monitoring, as an example, you're collecting less data to look at the network when you're hunting through all that and sifting through all that data. And that's because the industrial environment excels at network security monitoring. The data on the network is more static than in IT. So that kind of gives us, and we don't often have this, but kind of a little bit of a bump in the race. We're a bit ahead of the game for that reason. It's easier to find the needle in the haystack, essentially, in ICS, a little bit better anyways. Beyond that, of course, we'll talk about the threat hunting that's most effective when you have the data sources to sift through. That's not rocket science. It's not magic, right? So if we do have the data sources, we're really in a good spot. If we don't have the data sources, the return of investment from a technical perspective of hunting will go down. So data sources, as you'll find at the end of this session and the next session entirely, we'll talk about that, and you'll see the importance of data sources, of course. In addition, threat hunting cannot be fully automated. So there are tools out there. By all means, use the tools to streamline your team's efforts, and use those tools to get hunt data and sift through the data. Absolutely. However, there's not a technology that's available that can add the context that we're looking for. And that's why we need human defenders that know the industrial control environments and the patterns, and usually what the adversary will go for. And I will dare say that even the ICS folks should have a knowledge of where the adversaries may go in the future that's not currently documented as well. So technology alone is not going to save us. So this means we have to have dedicated resources, sorry, but it is the most effective way to do defense in ICS today, or anywhere. Now, the traditional threat hunting in IT environments focus on a lot of traditional operating systems and a lot of traditional protocols. So on the screen, you will see a general representation of what's called the Purdue model, which is generally a zoned or structured network of what types of assets exist in the industrial control environment. Now, I want to pay attention quickly. At the top of the screen there, you will see in the upper level, so the DMZ, for example, or even the supervisory control elements, all of what you see in this blue area is really the common industrial control environment. At the top level here, where you see in that the blue arrow to the left, this is traditional technology. In that area, you could see traditional Windows, Linux operating systems, traditional IT-related protocols, SMB, for example, SSH, Telnet, HTTP, HTTPS, and so on and so forth. And that's all well and good. However, we are in the industrial control environment. Even when we look at the specific yellow area down below here off to the left side, that is specifically more engineering devices, non-traditional operating systems, embedded operating systems, industrial protocols, specific security controls are needed to be in place in that area. Also in this area, safety is absolutely more of a concern as well. But overall, the entire map you see on your screen, this is an industrial control environment, even though we do have traditional technologies at the top part of that. So these are all OT assets and treated as such, which means when we're hunting, absolutely in the upper part of the Purdue, it's going to be familiar territory to some degree from those coming from IT and approaching it from a threat hunt perspective. When we get down in the lower levels of the Purdue, though, there's where we need engineering knowledge and awareness of what those systems are from a process perspective. And that's how we can be more effective really doing ICS-specific threat hunting. Of course, just looking at the screen, if we only did threat hunting at the top part where the traditional operating systems may be still as OT assets, we're not hunting for the full picture, and we could miss significant portions of critical data. So the whole range here is really the OT data, and everything in this series talks about the ICS threat hunting, and it goes right down through all of the Purdue levels you see on screen. Just a reminder as well, those who have questions, please pop those into the chat window. Super looking forward to answering your questions in just a little bit. So if we talk about the requirements to set up, your hunting exercise for ICS, what are you going to need for that? And yes, if you require to go to a physical facility, you will need protective equipment. So PPE will be part of your requirements. But in general, I want to focus on those three pillars, right? People, process, and technologies, and map that really to how you would set up a hunt for your technical team and how you would execute that as well. So you will see this slide throughout the series, and we'll map back to this when we talk about each element. So the people, process, and technology area, this is really going to be where you're going to fully understand that you need more than technology here. Now, first off, of course, the people are going to be trained cybersecurity professionals, and absolutely, it's a very important thing that they understand the engineering aspect. So those things in the lower level of Purdue, which go beyond the traditional operating systems. So that's awesome. We got that in hand. Awesome. The process as well. So this is where you have an established program in ICS, and also doesn't have to be perfect. So threat hunting out there is generally a more mature process or more mature part of a security program for IT or ICS, but you don't have to be a perfect program to do threat hunting and actually get a result, a positive result back to help your program. But it will help having some prerequisites in place, which we'll cover in the next section. So having something established, it's going to be much better than not having it at all. And starting with threat hunting, there's a lot of a benefit to having a lot of other things in place first, kind of like building a house, right? It's foundation first. The technology, as we know, it's not going to be fully automated, but scripts such as PowerShell scripts, for example, absolutely can be utilized. Automation to look across packet captures on the network, absolutely bring it on. We need that stuff to automate some of the threat hunting, to collect the data that we need to start sifting through for specific threat hunt hypothesis, right, as we go through our data. So there's the people, the process, and technology. And again, I really want to emphasize the people aspect, because you will have trained, hopefully, in folks focusing on sifting through that data with the context of the industrial environment. So when would you do threat hunting? How would you kick this off in the environment? And when's the best place? When's the best place to do this? So with that, I want to talk a little bit about the sliding scale of cybersecurity. You probably have seen it before, and that's awesome. So I'll relate all this back to that sliding scale and kind of talk about the nuances when it's maybe most appropriate to do so, and some of the things you might miss along the way if you don't do it at this certain time. Either way you do this, there's going to be benefits. So let's walk through this. So this is the sliding scale of cybersecurity, right? And here's the thing, threat hunting will absolutely not replace industrial control system security. Even in IT, it's the same thing. Threat hunting relies on things you have in place to make it more effective as you go. Even if there is data sources that you need you don't have, there's a benefit to know that you don't have them, and you can find that out through a threat hunt. A lot of threat hunts I have seen, they've really identified, that's a network over there we haven't been on in a while, but let's go sift through the data over there, and come to realize the data sources are not available, but they thought they were. So a lot of benefits from this and a lot of lessons learned. And we'll talk about metrics of threat intelligence and threat hunting in the next couple webinars beyond this one. So back to the sliding scale of cybersecurity. The sliding scale has a number of different positions in there. It ranges from architecture to passive defense, active defense, intelligence, and offense. What I want to do is focus on the lower blue area first, which is where we all should start any security program, and at least build and refine those parts before we move on. So architecture. Architecture is not something that you can go without and be super effective at threat hunting. So it makes sense to do a lot of architecture upfront. Not only is it actually cost effective to a program in general, using something like the Purdue architecture, putting that in place, zoning out your technical devices in the industrial environments has many, many benefits. Obviously, with incident response as a result, so you can actually contain one network while continuing to fight through an attack in another network, maintaining the system and the safety and the operational process. But we also can do additional things in this area as well. In the architecture phase of the sliding scale, it's not just talking about network architecture, the technical aspects. We're talking about the architecture of the security in your environment, in your facilities, such as, do you have security in supply chain where you get devices from? Are hardening processes being completed? And yes, don't laugh at this one, is patching in the industrial environment when it's safe to do so? We consider that the architecture area of the sliding scale. So highly recommend having this in place prior to do threat hunting. Same with the passive defense as well. So highly recommend having passive defense in place built on top of architecture to make it more of that sturdier house that will withstand threats and whatnot. So if we take a look at the passive defense, we're talking about ICS-specific antivirus as an example. That can be allow listing type, or it can be whitelisting type. So not typically a type of traditional AV that looks for signatures on the internet, has heuristics-based engines. Those can cause connectivity problems and concerns, but also things like false positives, which we really don't want to have inside of a safety environment. Beyond that, still in passive defense is the functional, I'll call it ACLs on a firewall, right? So this is Zones are set up to make sure that you don't have traffic in there unless it's appropriate for it to be in there, and you of course don't allow traffic and protocols that you don't allow. So that's all about least privilege essentially, which still is applicable, and the network perspective. So this would be a passive defense as well, sort of not a set and forget technology, but does not continuously involve human defenders to be on it all the time and leveraging it on a regular basis. So almost set and forget as passive technologies. Now, no surprise here, again, the benefits can be seen from threat intelligence and threat hunting in any maturity level of the sliding scale. But of course, we're now talking about the winner, which is active defense. And this is where we have dedicated human defenders focusing on looking through the data, leveraging threat intelligence, and applying that knowledge and context from the human mind to the data in the ICS, understanding what the adversaries can do and what they have been doing in the past. So active defense is really where you want to be. Now, again, premature threat hunting does help reveal the things you need for hunting, right? If you go looking for something and you're in the wrong place, right, and you don't have the data, then that's a lesson learned, which actually can be super effective. So I'm not saying start without architecture or passive defense, but as you go through active defense and doing hunting, you will find things that you can actually improve your security program over time. And again, active defense is that mature spot where we really consider it as a best practice security today for any industrial control environment. That's again, making sure people are trained in industrial control processes and security and applying that on a regular basis, dedicated, focused teams or person looking at the data on a regular basis who know the operations. So when would you be ready for a threat hunt? I would say the appropriate place to do a threat hunt, and again, any area can be helpful, but this is the most appropriate place where you're going to get the most return of investment for your technical team. Threat hunters that have that knowledge of the engineering process, they walk into a plant, and if it's a generation station, for example, they know what a generator is. They know that we're at a hydro plant, and that water comes through a penstock into the generator, and that gives us our electricity. That's an important asset. Like understanding that is critical. And of course, reversing that to understand how the adversary can target it, right? That's how you do threat hunting, understanding the assets. So the second one is exactly that. The second point is the asset inventory for industrial control environments. And this does not only include the traditional operating systems that are OT assets that could be used, like running Windows with engineering software on it, for example, such as the human machine interface and so on. The inventory in the ICS should have those, but also should have the programmable logic controllers, remote terminal units, the protocols being used in the environment, also the purpose of the assets inside the ICS, things like the IP addresses, MAC address, firmware versions, etc. All that will help when you do a hunt to understand your vulnerabilities, your risk surface, and so on and so forth. Beyond that, of course, again, the appropriate time to hunt is having the visibility. That means network visibility, endpoint visibility as well, including the engineering assets to some degree. So we will talk about getting data sources from controllers, for example, in the next episode. Human defenders focusing and looking at the network on a regular basis, and that's really what we're talking about, the active defense. So we know active defense is the best spot. What do we do when we get to active defense? How do we start an actual hunt? So next episode, we'll talk about building an actual hunt template and go through that. But before we do that, we do have to cover some data sources, or excuse me, some intel sources, where you're going to get your threat intelligence. Now, some of your threat intelligence to apply to threat hunting can come from situational awareness or expertise in the field who have seen threats before and understand how an adversary will work. But I do want to point out that there are several sources for threat intelligence. There's paid for services, there's not paid for services, and they have different ramifications and investments for your hunt program. So let's run down through the different types of threat intelligence that's out there and see what the differences are and how to map some of those into your program. So with threat intel sources, there are many sources out there, and your team is probably inundated on a regular basis with threat intelligence or vulnerability information or advisories. So you can see some threat intelligence in the form of software or hardware or engineering vendor advisories that come from the vendor that say, here's a hole or a vulnerability in some of our devices, and by the way, we're going to patch it or not. And there's related exploits for those vulnerabilities, and that can help you in your hunt as well. You can also get threat intelligence such as indicator feeds, indicators of compromise, or IOC feeds, technical indicators, from feeds that are available from several sources that provide a sticks and taxi format and data. So you can ingest some of this technical data for hunting into things that are compatible with sticks and taxi or other versions, for example, such as firewalls and endpoint protection tools and so on and so forth. But also you will get threat intelligence information in other ways, such as the strategic threat intelligence reports that come out on a regular basis. Vendors can provide these, government entities can provide these on a regular basis as well. And of course, for the technical aspect of a hunt, because that's what hunting primarily is, it's looking at the malware analysis reports as well. So things like the TTPs can also be helpful beyond just indicators. So the tactics, techniques, and procedures can be directly leveraged using something like a MITRE ATT&CK framework or other frameworks that are out there. So to summarize, it can come from a lot of different places. Technical indicators, from vendors, from strategic documents, for example, about threats and adversary campaigns, to malware-specific analysis, deep technical knowledge, and deep technical reports as well. So there are differences, though, in some of the freely available or no-cost tools that are out there in sources and some of the paid-for tools. And it kind of is get what you pay for. But absolutely, if you have no place to start, stay tuned. The next couple slides will run through some freely available sources that you can kickstart your ICS threat hunting program pretty quickly. So the no-cost versus paid-for sources, there are a number of different organizations out there that have great knowledge of industrial control specific threats and protections, detections, mitigations, and so on. And one of those resources is an ISAC, so the Information Sharing and Analysis Center. So if you're in the electric sector, as an example, there is an e-ISAC that will kind of help you, and you can connect with them and you can get specific threat intelligence, sector specific intel for the electric sector, and you can apply directly to your environment. So that's really understanding how adversaries have been seen operating, targeting, and moving inside of an electric facility, as an example. Great lessons learned from that. Beyond that, we did mention the technical indicator feeds. There's a wide variety of them out there. There's a link coming up in a second as well. But also you want to make sure that depending on your budget and depending on the differences between the no cost and paid for, keep in mind the timeliness, the specificity to the ICS or your sector can change and have differences as well, but also the general experience for incident response cases. We are seeing a lot of specific incident response ICS vendors have a lot of that knowledge and publish information on cases that they have seen. So there's a lot of differences here. Timeliness, I think, is one of the biggest things I've seen. There's generally a lag between paid for solutions and the non-paid for. The non-paid for does tend to be later on that they're published. And so you would typically get an advantage from a paid for service, but to each his own, do what works for you. And that's why we populate this slide with no cost threat intelligence sources, an excellent place to start with threat intelligence for your program. So you see a number of different sources here, anything from using the MITRE ATT&CK ICS-specific version, the Canadian Center for Cybersecurity, for example, the ISACs, as we mentioned, Department of Homeland Security, and so on and so forth. So there's several out there that are available to kickstart your program. Likely you have seen some of these before. And what I'll do as well is I will populate the chat window, if I can, with this information so anybody can leverage it directly from here as well. The slides are going to be available as well on the website later, but now you have the technical information in chat as well. So we know a little bit about when you would start. We know about how to start with getting the threat intelligence information from an environment and applying that from a technical perspective or reading about it strategically to start up your hunt process. Ultimately, this will lead you to where to hunt in the environment based on the targeting of the adversary in your sector and so on and so forth. And that'll of course guide you to the next area where it is, what do you look for when you figure out what the adversary may be doing in the environment? So this will all come. So generally I want to talk about the questions the team should be able to answer as they start up the program, or even now if you have a hunt program already in place. These are practical application questions for a threat hunt specifically to the industrial environment. So let's run down through these to understand how you can match up the threat intel with your questions and your environment to make your hunt effective. So threat intelligence can help you answer a number of these critical questions. For example, where, not when, but where do you start a hunt in the environment? Another example here of generally sort of a Purdue model, but we do have a number of assets represented here from the internet inbound through the environment, for example, right? And so where do you start here? Do you start at the lower levels where you have actuators and sensors, for example? Do you go to the controller layer? Do you go to the supervisory control system layer? Or do you start in the ICS DMZ, usually between the IT environment and the ICS environment? Well, the answer is it depends. So we're going to get to that as we kind of move through, but understanding where to start depends on your sector and where the adversary has been seen before. That's ingesting the threat intelligence primarily from your sector. Beyond that, what assets are critical? You know the assets better than anybody in your organization, what is critical for your specific business. And that changes on the sector. So if it is a cookie factory, for example, you want to make sure your ovens are probably protected, right? So these are critical assets in that sector. But of course, in generation, transmission, distribution of power, the generating station, as an example, the transformers and so on, all of these things are going to be critical assets. However, there are common assets seen among many ICS environments, and that's what we're going to focus on, looking at those critical assets. And the next section will talk about getting specific data from those critical assets. Beyond what the critical assets are, and there's like 5 to 6 main ones that you'll see across many of them as we talked about, you're going to want to understand what has been seen to be targeted the most. How does the adversary get in an environment and actually have an impact in the ICS, right? So that's what threat intelligence can help you answer this information to some degree with your nuanced discussion about what's critical for your environment. Beyond that, you have to specifically answer these questions about your environment as well, which are, can you detect initial access of the adversary? So if you think about how the adversary has gotten into an environment in the past, whether it's from a digital pivot through a firewall from IT into the ICS, or if it's from a transient device, USB or laptop being brought into a plant, for example, to connect, these are the things we need to talk about. And of course, when you answer the question of can you do detection for initial access, the next question, no surprise, is data sources that you have. The second point, do you have the correct data sources to even detect an adversary, let alone sift through it afterwards? Do you require information from the network and or the endpoint? And do you have that information from the network? The whole idea is to build up data available for you to sift through. Also, the engineering assets in the field, and some of you may know that some legacy devices in the ICS, such as controllers, may not have the ability to do logging remotely, as an example. They may only do local logging inside the controllers. That means you have to have a way to get that data out or go to a site. But newer types of PLCs can actually do syslog or something similar for data access and data security event logs across the network. So a huge win there if you can get to that lower level. That's where you're going to have more effective hunting and really kind of see what visibility you have and whatnot. A lot of great lessons learned from that lower level. More on that in part 2, though, and specifically leveraging threat intelligence. We're going to walk you through a quick example and kind of just guide you through the methodology of when you ingest threat intelligence in the environment. Well, how do you use it and how do you get a hunt set up and so on and so forth? So let's walk through this together. When you ingest threat intelligence information, there will probably be intelligence, obviously, on what the adversary has been doing. One of those could be there's indications that an adversary has been, and this is totally not a coincidence here in this example, the adversary got initial access inside the IT environment and then pivoted from the IT environment, maybe after they got a initial foothold in the IT environment, executing maybe PowerShell with some kind of malware for remote access. And then, of course, maybe they change a registry key on the IT environment to get persistence on the system. Of course, exploiting something to get there, which brings up the point about patching an IT. And then from there, lateral movement from the IT business network into the OT network through a trusted and critical asset such as the data historian. This information that's stored in the data historian is also targeted in many cases as well, because the data historian holds data about the process. So what's the mixture of a chemical or a medication you have, for example, in a pharmaceutical company? That recipe is going to be stored in the data historian. How functional or how good is your your processes for a generation of electricity and the demand for electricity, that information is going to be stored in the data store in an electric plant, for example. Also, from the lateral movement into ICS from IT, what about remote access attempts to get to the human-machine interface to directly change the environment, not using malware in the ICS, right? We're using the human-machine interface against itself to shut a process down or cause safety concerns. So all of these things will add up, and you can see the differences here between IT and ICS attacks. Also, connections to the programmable logic controllers. We have seen that unplanned change in the field where adversaries are connecting to controllers to change the logic in the controllers, which effectively directly change the plant floor from manufacturing to electric power and so on. Critical assets are coming out of this conversation as we kind of go on. Also, what about the threat intelligence that you'll leverage is talking about the adversary abusing industrial control specific protocols, which may not have security built in. So the ultimate question is, can we answer this question? Can we walk through this? And we will walk through this as we build through this series. In the last part of the series, we're going to take this example and go through the technical aspects of that to track an adversary through. All right, as we come up on the last couple slides for this session, I do want to remind everybody, if there are questions, please drop them in the Q&A. We'll get to those in just a little bit. So what have we learned so far on this first threat hunting kind of exercise, really, in the threat hunting part 1? Some of the takeaways are here. If you do threat hunting, you can do it without having a perfect security team and a security program in place. It will reveal missing data structures or missing data sources, which can be helpful. You're not actually hunting, but you know that there's gaps in your environment. So this exercise on a technical level can help you determine you have a lack of visibility somewhere, which you can enable, therefore enabling your ability to do detection in general. So a lot of good things can come from just threat hunting application, and you're not yet so far along the sliding scale where you're super active. Also, it expands the knowledge and the teams as well. So when you're doing threat hunting, it's not going to be in isolation. You might have to get data, one of a key data source, from an engineering device in the field. How do you do that? You're going to be talking with engineering folks and teams. So threat hunting can absolutely bring teams together as well for that common goal of safety and reliability of operations. Again, while you're doing threat hunting and analysis, you're preparing for proactive defense. But when there is an incident in the environment, this whole idea of building those teams are critical, because when incidents happen, again, in ICS security, you're not doing this in isolation. You're leveraging all the teams, which can be safety teams, engineering teams, and so on and so forth. Beyond that, of course, you're leveraging the cyber threat intelligence specifically for proactive defense, which is we're trying to go beyond just indicators of compromise and sweeping the environment to see where the adversary's been. In fact, threat hunting does exactly that, but it goes beyond that to use the TTPs of attacks and to understand how you can change your environment before the adversary even gets there, making it less habitable for the environment or for the adversary in the environment. Of course, it also uncovers active campaigns and threats in your environment as well. Also, misconfigurations from an engineering perspective. When you are looking at data this deep in the ICS, you can come across things like misconfigured devices, which engineers may have been looking for the cause of for quite some time. So if, as a security team, we have the data sources available to us, such as the network data sources, endpoint data sources, then we can give that to the engineers, work together to say, hey, you know what? We found something in our hunt. It's not a security thing, but this could be helpful because it looks like there's an issue there, and then pass it over to them. So we've seen a lot of value from threat hunting just by giving data to folks as well to do troubleshooting from an engineering perspective. So that's the main takeaways for this part. In section 2, as we pivot to our later webcast in part 2 of the series, we'll talk about identifying those critical assets. Moreover, we'll talk about the related data sources for those assets, and they go beyond just the Windows event logs and application logs as well. So we'll talk about those data sources which are critical, and also we're going to build out what's called we'll call it a threat hunt package template, and we're going to prepare for an actual hunt and run through a hunt in the following episode as well. So where are we in this series? At this point here, we're coming up on finishing out this first part. We talked about the benefits and where to start and when to start in the environment specifically, and this will build on the next couple as we go along. So that's where we are today. please remember the sliding scale of cybersecurity, the architecture of passive defense and active defense, active being the most, I would say, mature place to start, but again, benefits throughout as you build your active defense processes. With that, I'm going to cut into the Q&A section here. So at this point, I'm really hoping you guys have some questions in the chat window, which we can walk through. And I'm going to turn it back over to Carol to read those out, and we can answer some of those questions here for you.
All right, thanks, Dean, for your great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for Dean, please enter it into the questions window now. This first one asks, how does threat hunting overlap or align to pen testing?
Yeah, great question. So threat hunting is obviously different than penetration testing, because with threat hunting, you're not necessarily changing anything. You're looking for areas where the adversary may have been or may creep into. It's a really good question. And penetration testing is really a different aspect, because you're actually changing something in the environment. So penetration test is you're actively executing exploitations, for example, changing data on a system. And that's all well and good, but I would say the overlap is penetration testing can be used to understand how the adversary gets in, or using threat intelligence to prove that the adversary gets in. I think the difference is really the proof of it, right? Threat hunting is, here's what we know about the adversary. Here's the doorways they would typically go through, and here's some of the data indicating they might have gone through that door. Where penetration testing is using the same technology or same threat intelligence to say, yeah, they've probably gone through here, here, here. It looks like they may have. Let's actually go through the same steps they would have and change the system to see if it's effective. So I think that's a great question. There is some overlap in the initial stages, but again, one is looking at it and not changing the infrastructure, and penetration testing would be changing the system, which can have risk in the ICS as well, which I'm sure you're aware. So I'd be very cautious on penetration testing, generally doing it in a development environment first, making sure everybody's aware, including the safety team and engineering team as well, because we don't want to have unpredicted events in the environment. Great question. Thanks for that question, Mike.
All right, thanks. The next one says, what is your thought on the OT ISAC, ISAC?
Yeah, so I think there's different threat intelligence sources out there. There's that source as well, the OT ISAC. There are several others. I think whatever source you select, paid for or not, you really should judge or measure any threat intelligence source based on something called CART, which is how complete is that for my specific sector? How accurate is that threat intelligence for my sector? And also how timely is that as well, right? And how impactful is it for me to action that threat intelligence? So I would say that's an excellent question. With any threat intelligence source, compare it to how it's going to be applicable and critically actionable to you. So a lot of teams that I see today are ingesting all this threat intelligence, what we talked about in this session and more, and they just don't know where to start. And so focusing on a specific sector, if you will, OT ISAC could be one of those. A specific sector can give you more relevant data, for example. So I'd start there. Hopefully that answers your question. Great question.
All right, thanks. The next one asks, what is the best place in the ICS OT network to start threat hunting?
Yeah, so we will address that in a later episode, but I do want to talk about it here as well. If you recall, there's that Purdue model, right? And where would you start? Generally, we find that the adversary can come from IT. So looking at the data historian or looking at some network connections that lead into the industrial environment is a great place to start. Remote access also comes to mind as well. Generally, we rely on a lot of vendors to get remote access to environments for troubleshooting and things of that nature. So I would say that any connection to the ICS is a great place to start there. Also, any critical assets you've identified. So the human machine interface, for example, engineering workstation, those devices, which will go into way more depth in the next section, is a great place to start. So yeah, great question.
All right, thanks. The next one says, can you use the MITRE ATT&CK framework for hunting inside OT ICS?
Yeah, so it's a great question as well. So there are different versions or mappings, if you will, of the MITRE ATT&CK framework. So the MITRE ATT&CK framework, if you haven't been using it before, it maps the tactics, techniques, and procedures of threats that we've seen in the past and campaigns we've seen in the past to assets, to data sources specifically to help with threat hunting and so on. But yes, you can use the MITRE ATT&CK framework for ICS. There is a specific ICS version of the MITRE ATT&CK navigator, and it has specific ICS elements into. So yes, absolutely, and totally recommend it. It's a great pivot point to leverage as you're building a threat hunt, because it will talk about those critical assets generally and how to get data from those critical engineering assets as well. Yep.
All right, thank you. Is it better to leverage threat intel that gives IOCs or TTPs instead for hunting?
IOCs and TTPs, it's the age-old kind of conversation of which is better. I will say that they're different. They're for different purposes, whereas indicators of compromise, such as a hash, a file name, and IP address, is used to scope the environment to see where the adversary has been. A lot of value in that, typically used in some hunting exercises, but also incident response as well, which means an incident has already typically happened. So great value in IOCs, but they will reduce value over time, such as IP addresses will weaken over time. And so they might not be malicious when you're hunting, for example. TTPs, on the other hand, is really kind of the opposite of that, where it's really focused more so in hunting, at least on the proactive side. So as an example, instead of looking for IP addresses known that an adversary has used, a TTP would be, well, the adversary gets from the historian to the human machine interface, or talks to the Active Directory information server inside the OT environment. Do we have a pathway from IT into the ICS and that Active Directory infrastructure, or is there shared credentials between them? These are the things that we can ask when we talk about TTP specifically. So to recap, both are super useful. IOCs more so for some hunting, but also more reactive security, whereas TTPs is really more bang for your buck, right? Instead of playing whack-a-mole, you can get more strategic TTP action happening to reduce the habitable nature of the environment. So excellent question. And we will go into the differences more so in the next session as well. Yep.
Thanks. We are starting out with no-cost threat intel today. When should we consider professional or paid-for threat intelligence sources?
Yeah, that's a great question. So it depends on obviously the budget, but again, I go back to what the comment earlier where we had a question about a certain source. Any threat intelligence source I would really base on how timely is the threat intelligence being produced and provided to you to consume, but also how accurate is it for your environment specifically. And so yeah, I would focus on the CART methodology, making sure it's complete and timely and accurate to the environment as an example. But generally, you can get a lot of leverage from open source or no cost threat intelligence. Excellent place to start. I've seen organizations use only threat intelligence that's freely available for several years. But as you mature, you may want to understand what else is available. So going to a vendor solution that is specific in the ICS realm, who has done a lot of ICS incident response, can give you more timely information and likely more accurate information. But there's a lot of evaluations out there. So yeah, check out the vendor evaluations. That's a good question. Any other questions?
Thanks. No, that's all the questions I see for today. Do you have any closing thoughts?
No closing thoughts. Want to thank everybody for joining today. As we progress through this series, it's going to get more technical in nature. So hopefully this will be helpful for you. And again, thanks everybody for joining, and hope to see you in the next one, which dives deeper into threat hunting for the ICS environment. So thanks very much.
All right, thank you so much, Dean, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks, everyone.